So next we're going to learn how mass moles and molar mass are connected. So here's the formula that connects mass moles and molar mass, but just to make sense of where that came from, think about molar mass. The definition of molar mass is the mass for a single mole of your substance, right? It's the gram per mole. That's what your molar mass is. That's big M right there. If you were to multiply that by the number of moles that you have, well, then it would make sense that the thing that you get out of that is, well, the mass of the substance, right, in grams. You could even see this as just the units. You can see how those units would cancel, right? Moles would cancel moles. You'd be left with grams. That's what this formula really means. Just to go through what each piece is, you've got your mass first. The symbol for mass is lowercase m here. I know this gets a little bit confusing. There's little m, little n, big N. There's a lot of symbols that are similar here, so do be careful with how you write these down. That's the mass of our substance, and it's going to be the mass measured in grams. This is something to watch out for if you happen to be taking physics right now. The standard unit in physics is the kilogram, but in chemistry we use the gram, right? So not the kilogram. That's just because we deal with really small quantities here in chemistry. Next we've got moles. You guys know moles already. That's little n. Its unit is moles, M-O-L. And then the last one we've got is the molar mass, which is measured in grams per mole, and that's why we get mass in grams. Let's try an example with this. So let's say you had the iron sulfate, and you know its molar mass. You can calculate that from the periodic table, but maybe I'm given it of 399.88 grams per mole. And we want to know how many moles are in a certain mass of iron 3 sulfate, so 3.2 kilograms. Your first move in any problem is write down your given, and we're going to be really careful to write it down with the right unit and the right symbol. So for the first thing I'm given is the molar mass. The correct symbol for molar mass is capital M. And I usually like to put the actual compound formula as a subscript just so I can remember which compound I'm talking about. That becomes important when you get to more complicated questions that have multiple compounds moving around at once. So the molar mass of iron 3 sulfate is given to us. It's 399.88, and the unit is grams per mole. So that's already a good unit. Everything is fine there. Next, we write down the mass. Here's where I'm putting this in a different color in gray, right? Just to notice for you that this unit is wrong, right? We can't have the kilogram. We need to use grams. So the next thing we've got to do right away is switch that to grams. To do that switch, I'm just going to multiply by a fraction, and that fraction will equal 1. So I'm actually not changing anything. I'm just multiplying by the number 1, right? 1,000 grams is equal to 1 kilogram. So this fraction is just the number 1. But sneakily, I am changing the unit, right? Kilograms will cancel kilograms, and I'll be left with the gram. So when I do 3.2 kilograms times 1,000 grams over 1 kilogram, I'll get 3,200 grams. Now my unit is good, so that's perfect. So M is in the right unit. Notice that the symbol of mass is little m, and the unit is grams. Okay, next we write down what we're required to find here. We're asked in the question, how many moles are there? So we want to find the number of moles. That symbol is little n, so that's my required. And the formula we'll be working with is mass is moles times molar mass. So that's where we're at. All right, what does that solution look like? Well, we're going to take this formula. We need to rearrange it for n, the number of moles. And remember, we're rearranging our formulas using variables rather than plugging our numbers in right away. So I need to get this rearranged for moles. To do that, I need to get rid of molar mass. So let's divide both sides by big M. That will cancel the molar mass over here and leave me with n on its own. And then I'll just write that forward and prettier. So here it is. So little n, the number of moles, is mass over molar mass. It's all rearranged, so I'm good to plug in my numbers. The mass was 3,200 grams, and the molar mass, 399.88 grams per mole. Do that division on your calculator, and we'll get a number close to around 8. Now, how many significant figures can I keep? Notice there's 2 sig figs here, and there are 5 sig figs here. So we're going to go with the smallest number of sig figs, which is 2. So I need to write my answer down to 2 significant figures. Also going to make sure that my answer has a unit on it, and the unit is moles, and that I'm using the right symbol, which is little n for moles. That's it. Let's do a slightly trickier example. So let's say we had 0.56 moles of potassium oxide, and we need to know the mass of potassium oxide. Again, we think about our given. The first thing I'm given is just the number of moles. So the symbol for that would be little n, and there's my unit of moles. Now I'm also given the molar mass, but this I'm given in a sneakier way here. I'm really given this through the periodic table. So here's how I would write down a molar mass. I'll start by using the symbol, big M, for molar mass. Then, as a subscript, I write down the chemical formula for my compound. Potassium oxide is K2O. I know that because the charge on potassium is 1 and the charge on oxygen is -2. So I can see my chemical formula right there, and that tells me, well, how many of each do I need? I've got 2 Ks, so I need to do 2 times the molar mass of potassium. And I have 1 oxygen, so I need to add in 1 of the molar mass of oxygen. So I'm going to do 2 times potassium's molar mass plus 1 oxygen molar mass. And that gives me a total molar mass of 94.2 grams per mole. What am I required to find? Well, here I'm asked in the question what mass of potassium oxide this is. So I'm looking for little m. That's the symbol for mass. The formula we've got is mass is moles times molar mass, and so this is awesome. It's already rearranged the way we want it to be. So here I can actually just plug my numbers straight in. The moles multiplied by the molar mass right there. Multiply those out and we'll get 53 grams, and check your significant figures. There's 2 sig figs here, so there should be 2 significant figures in my final answer. Let's round it off correctly. All right, one last example. 5.21 kilograms of carbon dioxide. How many moles have we got? So let's write down what we're given. We've got a mass, but watch out, it is in kilograms. We need to switch that to grams right away. So once again, we'll multiply by a fraction that equals 1. To convert kilograms to grams, I'm going to multiply by 1,000 grams over 1 kilogram, because that's equal to each other, right? 1 kilogram is equal to 1,000 grams. That cancels the kilograms and leaves me with units of grams, which is what I want. That is 5,210 grams. So I've got the mass. Next, I need the molar mass. That's another given thing. It's given on the periodic table, so in kind of a sneaky way. And again, we write molar mass this way. So big M for molar mass, that's our symbol. The subscript is my chemical formula, which is for carbon dioxide, 1 carbon and 2 oxygens. So that tells me I'm going to need 1 carbon. So I'll do a 1 there of the 12.02, and I'm going to need 2 oxygens, so 2 of the 16. And you can see that's here. So the molar mass of carbon, 12.01, plus 2 oxygens, 2 times the molar mass of oxygen. That gives me 44.01 grams per mole. That's my molar mass. The thing I'm required to find here is, well, the question asked me how many moles are there. So I'm looking for moles. Symbol for that is little n. So that's what I'm trying to solve for. And the formula I'm going to use is mass is equal to moles times molar mass. So here's my formula. Once again, I'm rearranging this for moles. You do a lot of the same rearranging here. We'll divide both sides by molar mass. Kaboom, kaboom. And you get moles on its own is equal to mass over molar mass. We're ready to go, so let's plug in all of our numbers. The mass is 5,210 grams, and the molar mass is 44.01 grams per mole. Toss that into your calculator, and I get 118 moles. Let's check our significant figures. There's 1, 2, 3 sig figs in the problem, so there should be 3 significant figures in my final answer. And that's it.